Hello everybody, welcome back. So, this is going to be probably a multi-part video, but what we have here and what's a work in progress is a better anemometer. And the reason I say that is because if you buy anemometers online, typically you have three categories. You have the little handheld, little like fan style anemometer, which you hold in your hand and face into the wind and it'll read the wind speed. Then you have the more permanent mount, like the base mount style cup and wind vane anemometers. These are typically sold as a combo, as a weather station, something that you can mount on a pole in your backyard and use to monitor the weather. And then there's the third kind, which is the torpedo style anemometer. I think it's called torpedo style, I read that somewhere, that's what I'm calling it. And this is more so what companies like R.M Young are prone to making. Typically you find these located on buoys out in the ocean, or sometimes they're located on NOAA observatory sites will have this style of anemometer on it. And about a year ago I started experimenting with a homemade design where I 3D printed a body, I got a slip ring bearing, and I had a compass in there and a Hall effect sensor that was reading out the pulses as a magnet went past the sensor, and that worked pretty good. We're going to be attempting another attempt on this, and this time instead of it being a base mount like a house mount, we are going to put it on our vehicle. So R.M Young is really the only company that makes this style of anemometer, and in my opinion they are incredibly overpriced for what they are. They don't even sell like a lower quality tier. Everything on there is definitely commercial, like scientific grade almost, but they don't even sell a hobbyist grade piece of equipment. I think the lowest option you can get for one of these is around $1,000, and that doesn't even include the receiver. So we're going to try and build something using 3D printing and parts we have at home that will accomplish the same thing as an R.M Young with varying degrees of accuracy, of course, but we're going to try and make it as close as we can and make it something that you could do at home if you were so inclined. So to start off here, I've got some new parts that we ordered from an online seller. So when I made the original design, I based it off of this. This is a body for a torpedo style anemometer. This came from a French website, and I can't pronounce the name of the website off the top of my head, but I will try and link it in the description. They sell a couple different parts like this, and eventually I'd want to, design my own thing and have my own bodies made. But right now we have one of theirs. This cost about $30 if I remember correctly, and it has everything you need inside of it. It's got mounting port, what do you call this? Like a ring for mounting the thing. It's got a hole for a bearing and options at the back to mount a fin, and plenty of room inside the body for electronics. So my first attempt utilized this, which is the original slip ring and pole off of the setup with the electronics. As you can see in here, all I had was a Hall effect sensor and an electronic compass. All that did was pass the wires through the slip ring here, and it came out as an Ethernet cable down at the other end. So we are going to try and take these electronics out of here and move them to the new body. We have a much more robust design this time, so let's get into that. One thing that I noticed with the original was that in very strong winds, anything above 40 miles an hour or so, the slip ring that I was using, which is a Adafruit slip ring, it actually sort of would bend a little bit. You can't really see it on camera here, but it does have some give to it. And for a vehicle mounted anemometer, which is going to be experiencing upwards of 70 miles an hour constant wind while driving, added on to that, if you have a headwind, it could see anywhere up from 80, 90, 100 miles an hour depending on the wind. So we need something that's very robust and can handle extremely powerful winds. So that slip ring was kind of out of the question. Instead what I got was this. Here's the label on it. I don't know how much good that will do anybody looking, but I did get this off Amazon. It was a little pricey. I believe it was about $45, but this thing is very, very robust. It's got multiple bearings. The wires are thicker, which they didn't need to be, but they are. It's got a very nice mounting solution. These 3 set screws go into a metal rod, which I'll show in a minute. The only downside is it does have slightly more rolling resistance than this slip ring does. This right here rotates about the same resistance as the finest bearings that you could get. This definitely has a little bit of resistance, which is something to keep in mind. The only thing that will affect is measuring very, very low wind speeds. The fin at the back of the body of the torpedo style anemometer looks like this. It's pretty much just a square of carbon fiber. And if the wind is weak enough, there may not be enough resistance to push this fin into alignment. Now, that being said, I really don't think that's going to be even an issue at all, because it does have a little bit of rolling resistance, but it's so little that I think this will work no matter what. So let's talk about mounting this thing. I picked up this metal rod here. This is a 1/2 inch diameter, 3 feet long. It just says plated. I'm guessing this is stainless steel, but there you go. It's just a rod. eventually my plan to mount this on the vehicle, we're probably gonna have to thread threads onto this and put it in like a 3/8 by 24 style mount like you would use for a CB antenna. So we're going to sort of go through the process of building this thing into an actual vehicle mounted anemometer that behaves like an R.M Young, but at none of the price. And if this goes well enough, maybe I'll make these commercially available or do something to that effect. Anyway, so the first part is adapting this body to this slip ring. Now, I got into my CAD software and I designed a 3D printed little cylinder here. So the way this works is you take the cross section here, and this actually slides into it. It goes in there just like that. And then you tighten the screws down around it. You just sandwich the two halves together like that. And now you have a base on this thing which will actually fit over this slip ring. And then the way the slip ring mounts to the metal rod is really nothing more than just sliding the rod up into the slip ring like that. So this will rotate around it indefinitely. You can do as many turns as you want. The wires will never get tangled, and the set screws will keep it on there nice and strong. So we gotta turn this into a proper system. So what I'm gonna do is put this on here, and it does kind of go upside down. This is for two reasons. Number one, it's a lot easier to mount the rod through here than it is to build some kind of 3D printed base to mount a rod onto. The size was already correct, so we're gonna go with that. So this has a hole in the center. If I can show that on camera, there's a hole. And we're just gonna take the wires that come off the slip ring, feed them all through this hole. Now there's a lot of them. I think this has 6 wires. Should be all of the wires. Yep, it is, okay. So we got that, just like that going on. Now I'm just gonna sort of push this cap onto here. Now it's a very tight fit, so what I am gonna do is not push it down all the way. In case I do need to remove it eventually, I'm gonna sort of leave some room for error in case I ever have design plan changes, because I made that mistake the first time. I pushed it all the way on and I had to cut an old rendition of this thing off of the slip ring. So there we have that. The blue part's eventually going to slide all the way up in there, but we're going to save that for later. Okay, now we're going to do the body part. Now, so here's this. We'll start with this end. And let's go ahead and stick that on there like that. Here's another part we need to go over. The bearing for this thing. This bearing was also ordered from the same website that makes the body. I tried to make my own bearing and I couldn't really do it. I wanted to use something with very, very low spinning resistance, which this has. But in order to do what I wanted it to do, I was going to need a dual bearing style cylinder that could mount in here, and I ended up having some trouble with that because not only do you need the propeller to attach on the front, you need there to be a extension out the back to mount a spinning wheel of magnets on, pretty much. So that goes in there like that, and then we need the end here, and we're going to test fit all this first before we put the electronics in. But this is a very crude carbon fiber fin that I just made. Let's just tuck these wires up in here kinda. Alright, we got the wires kinda taken care of here. I'm gonna drop this down and put a little bit of glue down in here. Try and come out so much. That was starting to get a little annoying on there. Of course that glue is not gonna be there permanently. It's just hot glue, so it'll come right back out. Then we need to insert the bearing here. Put the propeller on it. And the front of the body, and then we put this here in last because it's kind of got a sandwich in there its own way. Alright, we're looking good. Got a couple of screws here. I believe this kit did come with all the screws it needed as well, which is pretty nice. Alright, we've got a couple screws and everything here. So now you can see what this design is starting to look like. Try to move this camera up a little bit. We've got a fin at the front, propeller at the front, fin at the back, and this is all mounted on a rotating bearing. So let's take this rod here that I got. Let's just shove it up in there. Again, this is all just a test fit to see how this thing does, because this has got to be able to handle high-speed winds. I mean, I'm talking, this thing needs to survive a dang tornado. I'm not having this thing break, okay? Anyway, here we go. There it is, mounted on there. You can spin around 360 degrees. There's a little bit of rolling resistance there. I am kind of feeling that rolling resistance. Just a little bit. But the most important thing is that if it's vertical, it can just spin and it's not going to try and do a whole lot. Yeah, you can definitely see how it stops. The old design would just sort of Like if I tilted it sideways, like it still turns when you tilt it sideways, but not as much as the other one did. So that's kind of it's not really a problem for a vehicle mounted anemometer because the winds we'll be measuring will pretty much always be enough. I mean, if I turn this thing sideways like this and I blow on it from the side, I mean, even that small amount was enough to spin this thing. Still, the old bearing would have turned a little easier. So that's something I'm going to be keeping an eye on, is that rolling resistance. But right now, the way it is, I am not too displeased with this. This looks good. So now that we've tested everything to see that it all fits together, we're going to go ahead and worry about the electronics now. I am going to have to 3D print a new ring. What I had initially was this ring with notches cut out for 4 magnets to sit on and spin around and hit the Hall effect sensor, but that ring ended up coming off the bearing in here because it didn't have a nut on it. There was nothing really keeping it on the bearing. So we're going to redesign this thing so that we can actually put a nut on it and make sure it doesn't fail. Alright, so we're going to have to design a new ring for this thing, a new magnet wheel, and I'm going to do it, we're going to make a 20mm circle, and then we're going to go from there. So from the center, we're going to go out 20mm, and I'm using Design Spark Mechanical to do this. So the next order of business is we need a hole for the center, and it looks like this center hole should be about 3mm big, and then we are going to do a set of little notches, but not notches on the outside. It's going to be enclosed, this ring is. So I'm going to make another ring here, and how thick do I want that outside ring to be? It can be pretty thin, but the 3D printer has to be able to get it. So since that was 20mm, we'll make the diameter of this thing 18mm, and that'll give about 1mm on either side for the 3D printer to be able to cope with it. So now we need to measure our magnets here and figure out how big to make our notch. So each magnet is 5mm wide by 3mm tall. So what we're gonna do here is we're gonna first create a construction line like that, and then we're going to right click and we're gonna set as mirror line, and then we're gonna make another construction line going across here, and we're also gonna set as mirror line. So now if we make just one of these little notches, we should be able to have it repeated across all of them. So now that we got those, let's just repeat it down here. We're gonna have, well actually, you know what, I think we are gonna run with just a 2 magnet setup, because this thing is gonna be spinning so fast that 4 magnets really isn't necessary. I had 4 magnets in there initially because I wanted to be able to measure the really low speeds, but it turned out that measuring the low speed stuff really wasn't even necessary, because it would just give you 0.7, you know, give you like the decimals, and I don't really need the decimals. And they're probably not that accurate either. So I guess we'll run with this, 2 magnets, and they'll be balanced. So this should work. Now if we move on, let's get rid of these construction lines first of all. We do not need these construction lines in here. All right, now we gotta pull this thing. Now I'm realizing here that because of where I put these boxes, we really don't need this second ring. So I am gonna actually delete that ring there, and we're going to run with this here setup. So if that looks symmetrical, which I believe it does, we're going to go ahead and extrude this thing, but we need to know how thick we can make it before we run into issues. So the maximum thickness that we can make this inner circle part here is 2mm. So we're going to go to pull here in Design Spark Mechanical, and we're just going to pull this design, make it thicker, and we're going to say 2mm. So that's as thick as we can make it. Now these magnets, however, are about 5mm thick. So what I actually want to do here is thicken one side of this. So we have to make room for the nut, obviously. So I'm going to measure how big around a nut is. And it looks like a nut is about 8mm at the widest. Now, of course, we got to give ourselves room to be able to tighten it down, of course. So we're going to make this a little bigger, probably about 9mm if we can. Looks like if we make it 10mm, that will give us room for the magnets and everything else. So we're actually going to make this 9.43mm thick. That way we have a little bit of a wall there. And then we're going to go into pull again, and we're going to just pull this another, see, we made it 2mm thick, so we're going to pull it about 3 more millimeters up. So let's go to, oh no, I want it to be 3, not 43, 3. There we go. Okay, that ought to do it. So that's going to let us put our nut in there, tighten down against the propeller shaft, and that will give us a nice little channel to slide our magnets into. So there we go. That looks pretty good to me, and we're going to go ahead and slap this on the 3D printer and see how it comes out. Well, there goes the weather radio, and on the top, oh my, Double headers, really? Is that what you call that? Double headers? Can't get any work done here. The weather radio won't stop going off. Alright, let's try and see if we can get some work done on this anemometer. So off camera, I had this 3D printed. It's the ring that I showed my design process for. It's got 2 magnets in it. It fits on the bearing and it just does what it's supposed to do. You spin the prop and the magnets spin like you're supposed to. So that goes in there just like that. It can spin freely. So what we're going to do here is we're going to remove the propeller and we're going to start adding the electronics in. So I have here the old slip ring and the old electronics. So we're going to desolder these and move them. So we also are going to heat up the glue gun here. So we've got 3 wires on the Hall effect sensor for the various things. We've got ground in the middle, power on the, I guess facing from the front. We have power, leftmost pin is power, center is ground, and blue is the signal wire. So I'm going to cut off these 3 wires from the old harness I had them on, and I'm probably going to just actually desolder them from these pins as well. We're going to separate these out, and that's going to kind of just sit under there like that. But we've got our 3 wires, so let me cut these a lot shorter actually. I'm going to trim off most of each wire because we already have a lot of excess wire that we don't need, and it's just going to take up space. So strip these individually. The weather today has been just crazy. Tennessee's been getting hammered. Here is not being hammered right now, but it probably will soon. Alright, so now we have our Hall effect sensor with the wires tinned properly. So we're going to just kind of set that in there, see how it looks. We got to make sure there's minimal distance between the sensor and the magnet. So we're going to have to lift this up a little bit, and I'll probably just do that when I glue it in. Because remember, this design right now is sort of temporary. Once we get this proof of concept going, I'll take it back apart. I'll 3D print something for the Hall effect sensor, something to hold the compass, and various other things like that. So, but for now, we are prototyping, and we can just try stuff and see what works. So I'll just put a little ball of glue on there, set that down in there like that. That looks good to me. Okay. Alright, we got our Hall effect sensor mounted, and if we put the propeller on and just look at the clearance on here, I think it looks pretty good. I'm looking at it from the side here. Y'all can't really see it, but I think it looks pretty good. So now we've got to wire everything up. We've got 3 wires here. We got power, ground, and signal. So the slip ring has plenty of wires for us to make use of. So I'm going to start setting this up. So we're going to use the green wire as our ground, and that only needs to be about that long. Now we do have other accessories that will be using the ground, but they will be having their own wires. So let's do that. Let's grab my other wire stripper, strip that back there, that. Go ahead and tin that wire like so. I do not need any shrink tubing for the ground wire here, so we're just gonna go ahead and solder that. One thing I actually just realized is that, dude, there goes the weather radio again. Oh my goodness. There goes the weather radio again, but we're just gonna keep working here. And solder this up. Once I get this finished, then I can actually do like storm chasing stuff. I don't want to do any kind of like serious storm chasing, but I think it would be kind of fun to mess around a little bit. Okay, here we go. So then here's a red wire. We're going to use this for power. Another tornado? Dude. Alright, there's our power wire hooked up. And now for signal. For signal, I'm going to go with, I think we'll do the brown wire for the anemometer signal, because we still need 2 wires for the magnetic compass. So we'll go with brown. I don't even have any heat shrink tubing on everything yet. This, like I said, is just purely proof of concept, making sure this whole idea works to begin with. I mean, I know it's going to work, but this is rapid prototyping. That's what I'll call it. Yeah, rapid prototyping. We're gonna glue down the the signal wire here because it won't need to be accessed by anything else, but the power and ground will. Okay, and now for the electronic compass here. Dude, I can barely get a word in right now. The tornado. There it goes again. Okay, well anyway, this is starting to come together here. We've got the magnometer put in there. Still got to connect the 2 data wires for that, but that's coming along pretty good. Alright, at long last we've gotten everything wired in. We have 1 extra wire if we ever need it. I'm just gonna like wrap this up around here or something. Well, there we go. We've got everything hooked up now and it's connected. Now we can start reassembling the body of this thing, and I'm gonna get a photograph of how everything's wired so that when we go to wire up the receiver, everything will be easy to lay out and figure out. Here's a better view of what's going on here. So we've got the Hall effect sensor and the electronic compass there. All the wires feed down into the slip ring and terminate as bare wires here. So we can now reassemble the 2 halves of this thing and get it looking better. As you can see here, the magnets pass by the Hall effect sensor. I think the Hall effect sensor is close enough. If it's not, we may have to move it closer. Alright, so we've got the anemometer reassembled here, and I've got it mounted on the rod. As you can see, we just have the bare wires coming out here. But here's the actual unit itself. It doesn't look too much different from the old design. The difference is just that this base is different, and we actually have a more solid system now for this thing going up on a car and withstanding 100+ mile-an-hour winds. The weakest point is probably this area here, although this has been printed with 100% infill, and I really don't think it will come apart in any kind of wind. Although if this thing were to get struck by some kind of debris, it would probably definitely break right there before it break anywhere else. So we'll see how it does. Eventually I'd love to get a piece of metal machined to fit this slip ring and slide on here. That would really be sweet, because I want to make this thing as robust as possible. But there we go. There's the anemometer body finished. And in the next video, we are going to go into the receiver portion of this, and then I may make like a 3rd video for the actual vehicle setup and install. So thanks for watching, everybody. And if you're interested to see where this product goes from here, definitely leave a like and a comment and tell me what you think. This is Scuffed Radio, and I'll see you all in the next video. Bye, 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 bye.